Welcome to The Explainer. Today, we're diving into a huge shift in how music gets made. We're asking the question, is code the new musical score? So let's kick things off with a big one, a question that kind of gets to the heart of everything we're talking about today. Can a computer actually compose a symphony? I mean, really compose one? It sounds super futuristic, right? Like something out of a sci-fi movie. Well, what if I told you the answer is yes, and that it's not even a new thing at all? In fact, a computer did just that way back in 1956. Yeah, you heard that right. And that little fact is the key to this whole incredible story. Okay, so look at this. On one side, you've got a language musicians have spoken for hundreds of years, the classic musical score. On the other side, a language for machines. Both of them create music, but they are worlds apart. And today, that old familiar score, well, it's starting to show its age. Think about it. The traditional score, with its dots and lines, was perfect for violins and pianos. It was an amazing invention. But it just wasn't built for the sounds we can make today. How do you write down the buzzing texture of a synth, or a melody that's constantly being generated by a computer? It's like trying to describe a movie with just a handful of words. The language just isn't big enough anymore. So that brings us to the big question, right? If the old way of writing music, the score, can't quite hold all these new ideas, then what will? What's the new container for the music of tomorrow? Is it going to be lines of code or something we haven't even thought of yet? That's what we're going to dig into. But here's where things get really interesting. You might think this whole music and algorithms thing is a newfangled techie idea, but it's not even close. The truth is, music has always been about rules and systems. You could almost say music and algorithms are old friends. Okay, before we go any further, let's just make sure we're on the same page. What even is an algorithm? Don't let the word scare you. It's just a recipe, seriously, a set of step-by-step instructions. You follow the steps, you get a result. So in music, an algorithm is just a recipe for making sound. And this recipe idea? It's ancient. We're talking 2,500 years ago with Pythagoras figuring out that music is basically just beautiful math. Then jump to the 14th century, you've got composers using something called isorhythm, which was basically a complex algorithm for creating patterns. And then, by the 1700s, the philosopher Leibniz is already dreaming up a universal language based on logic, a direct ancestor to the programming languages we use today. And check this out. This flowchart might look like something from a modern computer science class, but it's actually describing how to write a medieval song. It's a form called the virili. See? Step 1, do this. Step 2, do that. It's a strict, repeatable process. It is, for all intents and purposes, an algorithm. And this was hundreds of years before anyone even dreamed of a computer. So for centuries, the computer executing these musical recipes was a human being, a musician. But then came the 1950s, and everything changed. For the first time, this abstract idea of a musical algorithm met a physical machine that could actually follow the instructions all by itself. And that brings us right back to where we started. This quote you see here, this is it. This is the birth certificate of a brand new era. This is the exact moment a machine, for the very first time, processed the logic of writing music. The piece was called the Iliac Suite. And yeah, it was named after the beast of a machine that composed it, the iLab computer at the University of Illinois. This wasn't just some wacky experiment. This was proof. Proof that a machine could think like a composer, and it was a moment that would change everything. So how on earth did they pull this off? Well, it was messy and very, very manual. I mean, first, they had to write the whole program out on paper. Then, a team of technicians had to physically plug in wires and flip switches to hardwire the logic into this massive machine. And here's the key thing, the computer wasn't making any sound. It was just crunching the rules of music theory. The final output wasn't a recording. It was a printed score, ready to be handed to human musicians to actually play. So we've gone from physically plugging in wires in a room-sized computer to, well, today. The change has been absolutely explosive. Now, composers have this incredible digital toolbox filled with all sorts of powerful algorithmic tricks. Let's talk about one of the most fundamental techniques out there. It's called a Markov chain, and it's basically a game of probabilities. Okay, so here's how it works, and it's actually pretty simple. Imagine you're on a specific musical note, let's say a C. A Markov chain just asks, okay, based on the music I've already analyzed, what's the most likely note to come next? It's a constant game of what's the best next move. And the crazy thing is, it can generate music that sounds surprisingly natural and, well, musical. And this image here is a great way to see how that works. It's called a Markov matrix. So you look at the current events on the left and the next events across the top. The numbers inside tell you the odds. For example, if our music is currently at event 2, there's a 50% chance the next event will be a 1 and a 50% chance it'll stay at 2. It's like a roadmap of musical choices all laid out in probabilities.
And that's just one tool in the box. There's so much more. You've got genetic algorithms, which basically evolve music, like survival of the fittest for melodies. There's cellular automata, which create mind-blowing complexity from super simple rules, kind of like how crystals grow. And then there's my personal favorite, live coding. This is where the composer is on stage, writing and tweaking code in real time. The code isn't just the score, it's the instrument and the performance all rolled into one.
This quote here, which is from an Italian thesis on live coding, just nails the whole vibe. It translates to, economy in writing is more important than intelligibility. What does that mean? It means in a live performance, your code doesn't need to be pretty or easy to read. It just needs to work and it needs to be fast. It's all about what you can type in the heat of the moment to make the music happen. Okay, so this brings us full circle. Back to that huge question. If computers can do all this, if algorithms can generate melodies and harmonies, then where does that leave the human composer? Is their job on the line? This really highlights a massive shift in how we even think about music. For a long time, music theory was about taking a masterpiece apart, like a mechanic with an engine, to reveal its hidden structure. Algorithmic composition completely reverses that process. You don't start with the finished product. You start with the structure, you build the engine, and then you let it run to generate something entirely new. So here's the real takeaway. The composer isn't being replaced, not at all. Their role is just evolving. They're becoming less of a note writer and more of a system designer, an architect of musical worlds, a curator of possibilities. They're not just writing a song, they're building the universe where the song can exist.
And that's where we'll leave you, with one last question to chew on. As the old lines between score and code completely dissolve, what does the composer of the future even look like? Is it a musician who has to learn to code? A programmer who picks up an instrument? Or are we about to see a totally new kind of artist emerge? The symphony is definitely changing, and its new language is being written right now, one line of code at a time.